the area under the curve, any irregular curve, was eventually found by this formula. This is called the definite integral. Now, let's say if I have a curve like this, and I want to find the area from A to B, that means this point, these 2 points, then the easiest way is you draw the trapeziums, right? This trapezium has fixed width and they are equal width. So these are equal widths. I call this width as x, right? Now, this x value, if I make this x value very, 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 very small, that means I can create infinite trapeziums between the 2 points. Yes or no? So I can say this x is basically called change. Basically, this x is x1 here and x2 here. Basically, x2 minus x1. That is the width of my triangle, width of my trapezium, or height of my trapezium in this case, of my trapezoid. That's the height of my trapezoid. I will call this as dx. Delta x, change in x. That is what I'm calling. So in the world of calculus, you don't write x2 minus x1, you say dx. Dx means change in x, right? So if this dx is so small that it is almost zero, approaching zero, that means I can create infinite rectangles between A and B. Yes or no? Because the width is decreased. I can slice and dice infinite trapeziums, right? Infinite trapeziums when my dx is almost approaching zero. So in that case, how will I find the area under the curve? All these infinite areas combined together, right or wrong? All those infinite areas combined together. In general, the area is f of x dx. F of x is the y. Consider this to be, if you consider this to be a rectangle, let's say if this is a rectangle, then you have infinite rectangles rather than trapezium. So be it. So what is the area of rectangle? Length. This is length, f of x, the y, f of x1, and the width, dx, right? That is nothing but area of a rectangle. Yes or no? Yes or no? Simple. How many areas? This is, so should I say f of x1 times dx? X1 is my starting point. And now I have added infinite x infinity dx. I have to add all of them. Right or wrong? This will give me the area under the curve. So now I don't like writing this up. So I write it like this. I say, okay, add all. This is the sigma. This is called sigma sign. Add all rectangles of the length f of x times the width d of x in such a way that d of x, and in such a way that limit my d of x should approach zero. That is when it will become infinite rectangles. Yes or no? And how many rectangles am I adding? I'm adding n rectangles. I don't know, n could be infinity. This is area under the curve by adding infinite rectangles of a very, 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 very small width of equal size. Later down the track, scientists, not scientists, the mathematicians eventually didn't like writing this up, these symbols. So they said, okay, hang on, let's simplify this. Let's replace it with this sign. This sign is also sigma. Add all rectangles between the 2 points A and B by drawing infinite rectangles of the length f of x times the width d of x. And this became the area under the curve. Simple, right? Area under the curve. And this, in the world of calculus, they started calling it as definite integral. An integral which is definite. Integral is what? Integration. Integration means integrate. Integrate means join together. Join together all the rectangles within a definite boundary, A and B. And that is why it is called definite integral. Definite integration between 2 points A and B by combining the infinite rectangle's length times its width, which is the dx, is the width, delta x. And that's called, and now what do I get? Area under the curve. That is the concept of what definite integral is all about. They took out rectangles, length time width, between the 2 points, joined them all together with very, very small width, and it became infinite. It became definite integral.